There was a little bit of communication confusion around the actual subject of the talk. I know it got summarized as staged compilation because that was 2 words that existed in the abstract we sent. But it's more about lessons learned implementing StreamBase, which does a small amount of compilation at different times, and our CTO is eager to declare that staging. So that's basically it. Here's the rough agenda for the talk. You're going to see a slide like this come up a lot as I move through it, so don't bother to try and read it all now. What is StreamBase? StreamBase is a graphical language for complex event processing. What you see up there is actual StreamBase code. The graph itself sort of shows how data flows through the language, and then there's a detailed view. You can see the isNewBestBid operator is selected, and there's a detailed view that has an expression language that allows you to manipulate data. In the language itself, data is immutable. No, really, immutable. And you get an expression language to transform it at each step in time. But you get some free bonuses, like your debugger lets you look back across the states of all the historical transforms. You can store data in the diamond-shaped thing called bids and asks in this case. It's a query table. And it's it's SQL-like. It's much smaller than full SQL, but lets you have indices and things like that to access the data. I'm not going to spend much time on the syntax or semantics of the language. Those are very rich things, but it's useful to know just to have a sense of it, right? It's an event processing language. This means that it is really fundamentally designed to take in hundreds of thousands to millions of events per second and respond to them in microseconds. And those are the sort of sine qua non of the language. So our customers are frequently banks, hedge funds. There's some security firms that do intrusion detection, things like that. But that's the sort of recurring themes you'll see is you need low latency, you need to handle data effectively, and you need a rapid development environment. This talk won't go too much into what that entails. That could be another talk in and of itself. So here are the lessons learned while we've implemented it, because as with any language that's been developed for 6+ years and commercially deployed, you learn some lessons along the way. The first is in some ways obvious and in some ways the most painful. Spaghetti code is bad. Spaghetti code generation is much worse. If your compiler has people coming from all over poking bits of code into the generated output, it's orders of magnitude more difficult to untangle, and it's orders of magnitude more difficult to maintain backwards compatibility as you attempt to clean it up. I don't have a pithy slide for this. I suppose I should have just done a Google image search. Oh well. One of the big things we've learned, especially in a rich DSL like StreamBase event flow is you should actually carefully think when you're doing something whether you should be generating code or writing a runtime library that the server will use at runtime. Within StreamBase, we refer to these as writing code in the passive voice or the active voice. Anyone who's written a lot of English understands the torturous constructions that one is forced to use when one writes in the passive voice. I may or may not have succeeded in using a passive voice sentence just there. Naomi is telling me I did not. Alas. And you get a similar thing, when you were writing compiler, when you're generating bytecodes, you end up generating things that then run versus just writing code. It's much easier to do just about everything when you can write the code directly. But unfortunately, it tends to lead to polymorphic call sites. It binds things more directly. And you can't get any sort of type specializations. Type specialization comes up a lot because it provides most of the speed you see in StreamBase. Generated code allows you to, because you have the level of indirection at compile time instead of having the level of indirection at runtime, you can eliminate most of the runtime slowdowns for your indirection. So that's where you get really most of your speed improvements. Of course, it's easy to generate a lot of code by mistake. Sometimes you hit the 64K limit. I'm sure I'm the only person in this room who's ever done that, though. So we've sort of slowly converged on a general approach for how to structure our code in order to avoid, or in order to get some of the best approaches of both worlds. We use what are, generally speaking, abstract classes that do all of the structural, like what happens, but none of the type manipulation. And then we generate specialized versions of them that just do type manipulations. And they almost all of these generated things start by taking whatever base class they're handed and heroically downcasting them to what we know full well they will be. So as a sort of similar note of that, all expressions you see in the language, all mathematical expressions, because they're naturally dependent upon their types, they're generated. Similarly, application control flow of what goes from where to where, we also generate because that just avoids the virtual dispatch. So here's a simple example of something out of our disk query table, primary key, somewhat simplified and cleaned up for fitting on a slide. All of the methods in bold are abstract and interact with types. All the rest of the control flow we can actually just keep in a runtime library. It gets it a lot easier to debug, and you can actually put shim facades for your tests where you don't generate anything and you have an actual subclass of it that lets you test it. It's much easier that way. So similarly, we've just learned consistent APIs are an easy lesson. Everyone knows it. I'm sure many of us have said that even here today. But you can also have similar APIs. If you have one for manipulating bits like this, you can actually have one that for manipulating bits that when you generate it. And those of us who have to program against these APIs, if you have a consistent naming convention, like suffixing gen on everything and having identical method names, can get up to speed a lot faster. You'd think it goes without saying, but sometimes things need to be said. Type specialization really, really makes things fast. It's one of the biggest things in our language. It makes all of your call sites more monomorphic. It lets you unroll all your type loops. You can avoid garbage. That's actually one of the biggest things we have to do in our apps is avoid garbage. Yeah, we really want value types, by the way. On the minus side, it does lengthen your compile time. And so we've done some tricks to try and share compilations, and I'll get into those in a little bit. And once again, yes, it can hit those massive 64K methods. Separate compilation. Man, I wish we had thought of this in the very beginning, because retrofitting in separate compilation is something that takes time. We've sort of taken a approach of getting it in along with getting some of the other features we wanted, like shared compilation. So I'm going to go through sort of what we ended up with implementing to get us along the way. What you have here is, so on the left is the thread in question that's trying to generate some code. It could in fact be one of the compilation threads on the right, or it could be a different thing that's doing mainline compilation or even a dynamic eval. But the basic idea, and as earlier, I probably should have said this out loud when I was in the slide, DC is just the base class for all our data. It stands for data class because, yeah. So the code at the time of generation says to the compilation manager, get me a gen object for a data class, and it provides the types it needs. And the compilation manager responds to you, shit, I forgot to log out of IM. And the compilation manager responds to you, here's something that you can use. I promise it'll be there eventually. right? And then it goes and it checks whether it's there or not. It's usually there, but we're going to say it's not for the sake of explication. It then starts off a compile thread to actually compile them, which will eventually return a compiled result, which it then saves to disk. And of course, it will fulfill the promise, but the code generation all this time has been able to keep going just using the promise, and it doesn't get forced until the very last step. And so you can get some amount of speed up this way. It depends how much you've already compiled. I mean, the nice thing is after you've compiled 20 or so apps, it turns out there aren't that many combinations of primitive values. Well, there are, especially because it turns out most people have rows on the order of 60 to 100 fields. But there's a lot of repetition in them, so you can get a lot of commonality and you'll just splash off the cache. There are details in when you produce artifacts, you have to save off the shared portions of the artifacts and restore them to the disk in the appropriate spot, but they're not particularly interesting details. So class loaders, yeah, they really do hurt. We've run into issues with them in the past. You want to share them, but it's important to get your hierarchy right in the beginning. The hierarchy we've ended up with, we allow in our server multiple containers, which are at the bottom here. We allow multiple containers, but the containers need to be in separate class loaders, except that when you hand data between containers, you want to just hand a reference between the two things, and so you need all the shared things to come up higher. There have been points in our history where there were very dirty hacks in our class loader containers to specifically ignore particular package names because we didn't have this sort of a diagram and this sort of cleanliness to it. Also, the life cycle of your class loaders is annoying. You will run out of permgen if you don't get it right. Also on Windows, for quite a while, class loaders just behave differently enough. They mem-map things, sometimes they don't close them. If you're on class loaders in Windows and aren't on the latest JVM, you'll feel more pain. Improved tooling is actually one of the biggest benefits that we've seen. So StreamBase, if you might have noticed in the very beginning, provides a development environment in Eclipse. And so we have Eclipse developers on staff. And using them to help us actually produce better tooling to help us develop has been an immense win. So as a small demonstration, here I am in Eclipse that's much smaller than I'm ordinarily used to. I can run, and we have a small XML language just for actually defining small tests over our systems. It was a historical quirk. It was actually developed back when our thing was in C++. And so there was a jig that ran it. And then when we converted from an interpreter in C++ to a compiler in Java, we just implemented a new jig. So it actually provided a great deal of benefit. So you saw how long that ran. That was about 15 seconds for 35 tests. But it turns out if I hit this little C up here, I can switch what my backend is and run this single test. And it's going to take a lot longer because now it's actually going to save to disk a great number of the artifacts that it would be compiling directly in memory. But star map. Yeah, I mean, what's the thing I'm trying to type here?
Map _XML.
There it is. And so one of the more fun tricks we've picked up in this is these comments are actually the line of code that was responsible for generating that moment in it. It is unbelievable how much time this saves. It's also unbelievable how much time this costs, and you're creating new exceptions and groveling the stack. But we don't do it in release builds, or we don't do it without the proper system properties. And in fact, we've gone a step further. I can force it to take a little bit longer. If you're wondering why I keep hitting this little nuke button, the nuke button will destroy all the generated sources so that they don't taint my boot class path loader. If you're not careful with Eclipse, you'll get some of these gen sources into your boot class path and some not, and then Eclipse will give you truly archaic error messages. Now, of course, if I were paying attention, I would have remembered what I typed. Hey, but you can see now you get a greater stack depth for it. And this ability to very quickly play around with what bits of debugging you're getting has just been invaluable. And the moral of this story is I'm now running like way ahead of my estimated time. Yay. So rather than go straight to the shameless plugs, I'm going to instead actually show a little bit of the debugger that StreamBase has, because I have time. And I'm just going to hope that this works. I actually haven't tried it yet. So at this point, I'm flying off the prepared record. I apologize for all things. You might notice that's actually a quirk of Xmonad and Eclipse playing together. They don't particularly like each other. So let's load a StreamBase sample. Do you remember what that one we were just at was? Best bit ask? Yes. So I guess at this point I'm going a little more in depth into what StreamBase looks like. Hi there, error log. You can ignore that. I'm actually just running top of trunk, so if something goes screwy, I assure you our product is absolutely bulletproof. So this is what you probably saw earlier were the predicate settings on is new best bid. So one of the biggest things that leveraging Eclipse has leveraging both the JVM and Eclipse has gotten us is the ability to leverage the debugger directly in Eclipse. So I'm going to try and run this, hope for the best. It might complain that my license is out of date. Oh no, it's complaining about my compressed oops. Haha. All right. I'm going to be sad. So what may have just happened is it might have picked up ECJ off my system instead of the JVM that's actually installed. And so we cheat horribly for just one moment. Like I said, at this point I'm running slightly off the radar, or off the beaten path. And the thing I want is Java under, no, not in my command line history. Opt user local sbdeps jdk16 Yeah, I have a lot of these installed. U30. And Java home. Yeah, we've all done it before. So this time it should actually come up. Yeah. Apologies. If I send data, will it get out of the query? Send data to nicey feed. No. I need this to, oh, I'll just move my breakpoint. That would be an easier thing to do. Oh, come on. Am I running this and not, yeah, I'm running this and not debugging it. I'm sorry. Rookie mistake. So when I send data, the idea is you can get this nice graphical, oh man, I wish I had more screen real estate. This is sort of a refrain for my life working in Eclipse. you get this sort of a setup, and in fact, we can also even expose some of the internal stack frames that we hide when we're just doing it ourselves. So that's sort of the recurring theme in all of this, is really enriching your environment while you program makes the whole process a lot better. Wow, I might be the only person to finish with time to spare. So StreamBase. Many of our customers come to us and say, how amazing is that? I could implement that. And the answer is probably anyone in this room could implement it with 6 years. I mean, especially after you bear in mind that there's a full working debugger. There's also a tracing debugger so that you can do more omniscient debugging style things, and a raft of adapters to hundreds of connectivity feeds, all the ones you can name in most of the financial markets, and a bunch of utility ones like CSV. You can also feel free to play with it online. It's available for free online for limited periods. And we're hiring if you're in the Boston area, or even if you're not entirely in the Boston area, as Naomi works in San Francisco and I work in New York. We've given talks in the past at Debs, probably will again. And unrelated to anything, I'm going to put in a shameless plug for IDDS. It's an organization that does developmental stuff in third world with increasing incomes. And I'm putting this plug in there because I wrote the slide. Yay.